and post that link on IRC or post on Twitter, or any of your friends in the industry, in the community that want to see these talks live, feel free to point them in this direction. Okay, so we're going to start up our next session. You can see the schedule up there. We have a couple more talks and a couple more sponsor talks and a panel, and then we'll do a break for lunch, which is right in the same building just downstairs. So first we have Syam from Intel, and he's from the Munich office, and he's going to be telling us about their use of OpenWrt.
Thanks, Kathy. So, welcome back from the break. This talk is more about how do we use OpenWrt in the Intel CPEs. So just to give a background, that's a very bland title. We do understand that's probably one of the most bland titles you could ever give for the talk. The intention is we really want to explain what are those parts of OpenWrt which we use today, and which ones are the ones where we actually add more proprietary components and actually ship. It's important for this community because it's first of all an acknowledgement of all the good work this community is doing. And on the second part, we would also like you to focus on the hard part, where as organizations we feel these are the components which are missing. And that's the reason why we would like to little bit share insights into how do we use OpenWrt. So with that, let me get started with the agenda. So a quick slide, we go through the Intel and open source. UGW is our reference kit, is our SDK with which we ship all the Intel CPEs. So we will go through a little bit of a release calendar. It's what happened in the past, and then we dive deep into the design decisions and how did we use OpenWrt. So with that, yeah, I think Olaf, my colleague, gave a good talk already. Intel is one of the most active contributors in the open source. A lot of work and a huge open technology center, open source technology center, where you can get a lot of information on many different projects. So that's really the legacy of Intel. And as Connected Home division, we would like to definitely engage more closely, and that's also the effort we do with prpl, also with the OpenWrt community. So it's a lot of activities, and yeah, we would like to continue this good work from Intel. Now, let's jump a little bit into this UGW stack and the release calendars. So as I said, UGW is really the software. It's called Universal Gateway Software Package, and that's what we ship today. That's called UGW 7.2. It's just a version name. That's based on Chaos Comma. You can see it's on Chaos Comma, and our OpenWrt usage goes all the way back to attitude adjustment, or even, yeah, a little bit of kamikaze even. But that's attitude adjustment is the big step where we started using OpenWrt. So in between, what you can notice here is in between the 6.1.1 and 7.1.1, we did a major architectural change, and that's what we will be discussing a lot in these next few minutes. So we made it a lot more modular, and it's also a higher use of OpenWrt. Like the colleagues from Technicolor said, the intention is definitely to decrease the proprietary components as much as possible for the benefit of both sides. So that's, yeah, the high-level roadmap or the calendar. So we are based on Chaos Comma as on today. And yeah, we continue to ship based on this. So the next question which we get is, how are you using OpenWrt? Which component? So I just want to give a quick view of the components and what do we use? How do we use these components? So in a standard reference kit, we completely use all the IPv6, the netfd, the ubus, and the procd. So these still form the fundamental pieces. We will see it also in the design discussions later on, but these still form the fundamental pieces for the architecture. So that's 100% reuse from OpenWrt. The complete build system, the kernel, the patches, the toolchain, that's all from OpenWrt. And there is Lucy or UCI. We use it partly. We don't use all of it. We will also get to see that in a minute. So that's quite a lot of software from OpenWrt. So we would like to acknowledge, thank you for the community, for all the good work. I think some of these pieces are complex pieces, and we are using these pieces in our software. So that's a component reuse from OpenWrt. Now let's just get into what do we miss, what do we have in UGW. We want to go back almost 3 years. Why do we mix up some proprietary components? What do we miss? So if you just roll back the calendar 3 years, what you see is we have an attitude adjustment that's back in 2013, a barrier breaker in 2014, chaos calmer, and there are a lot of things happening between barrier breaker or all the way up to the barrier breaker. So that's some good work. Purple formation happened somewhere in 2015, 2014, and then CIG in 2016. So a lot of these events happening in parallel. And that's around the same time we decided that we need a more complete package which is capable of carrier ready or production ready software. And so that's where you see we are looking at a complete TR69, VoIP, web, all included, a complete package based on UGW. So that's the timeline we are talking about. So all the decisions we discuss right now are in the context of that timeline. We will come back and we will also see what changed in the last 3 years and how could we revisit this topic. So how is OpenWrt looking like in 2014, back in 2014? So that's, I think NetIFD, ProgD, UBus, all of them have stabilized. They're working pretty decently, pretty well. So that's really the good part. It still continues to be infrequent in terms of its releases. The cadence is missing. We see sometimes 1 year and a half, sometimes a year, sometimes less. It's kind of missing a modern GUI, or in other words, it's still very Lua-based or Lucy-based GUI, which has its own advantages and disadvantages, but that would also, Lua would also limit the number of developers for a software which goes out as a reference kit. And it's also missing some of the carrier readiness, what we discussed in the carrier interest group in purple, TR69, some of the daemons, and also production ready support. And the last one, it's missing a common low-level API. It's good to see OpenWrt supporting a lot of different SOC vendors, but it still does not have a common API where the stack can remain independent of the SOC or remain independent of the manufacturer's low-level content. So that was the state of OpenWrt in 2014, and because every time we come around with the same question, what is really carrier grade? Why do you say this is not carrier grade? I think friends like Technicolor, they understand, and we have also seen some of this content in the same slides, so it's good to see there's a good match in these slides. So what we are talking about, I'm sorry for the small font, but what we are talking about is really TR69, multicast, DSL and voice features, and DSL is more complex, like WAN auto detection, multi-WAN, auto switching, and then QoS with the ability to do the classification in the hardware, a web GUI which is a little bit more user-friendly, config management, secure boot handling. So each one of them is a big topic. We don't have time to really go through it, but we would be happy, all of us would be happy to really go into a little bit more detail later on in the breaks. So these are some of the things we have added on top, just to give you an idea what changed, what additional components did we bring in. So those are the components Intel has added on top of that. And coming to the design decisions, as I said, one of the things which was hurting us was really a lack of low-level API, and this was hurting even internally because the silicon evolves. The architecture of the silicon is very different from generation to generation. And we really needed to get this in control. We had a different acceleration block, a different switch, and different engines. So we wanted to see if we can abstract the higher level software with a much better API. And that's what we tried to do with the FAPI, what we call as a functional API, because it does not really understand which particular device are we talking about. So that's without FAPI, this is typically what we do. Let's take a flow more like a multicast, which is complex. It's complex because it's not specific to a particular interface or a particular engine, but it needs to be configured across we need to talk to probably the switch, the acceleration engine, and probably also some other components to make the whole multicast flow work. So that's typically covering not just one API, one driver, but it's actually cutting across different subsystems or different silicon parts, and that was giving a lot of complexity in the software. The init scripts or the handling, yeah, it was all over the place, and from silicon to silicon we were struggling with this. So what we did in the 7.x is we wanted to abstract this with a API which is more at a functional level, and that's where we say it's a multicast is a functional level API. It just talks about multicast, but does not talk about which acceleration block, which switch, and this could be very different between silicon to silicon. So that's what we tried to do with the FAPI, and you see some examples of it, multicast, DSL, LTE, wireless LAN. These are blocks where we actually wrote FAPIs, and with this we had the ability to move across architectures. And from Lantic, when we also became Intel, we had a completely different architecture called Puma, and this code runs on Puma also with the same architecture. That's possible only because we really had FAPI, and the FAPI was abstracting the hardware well enough. So that was one of the key design decisions we took, and that cleaned up a lot of our internal dependencies between modules. And then the next one we had to solve was, how do we work with OpenWrt? It's good to reuse. We know if we change a lot of OpenWrt, we also need to upstream it. It's not good to keep it as a local copy. So we try to look into the details of how OpenWrt works when you integrate with a third-party application. So this is a view on how we see it. So typically, OpenWrt works with a PROGD, which is really the heart where all the daemons register themselves. All of you are experts, so we don't need to go into the details. And then you see a interface either through Lucy or UCI. You write it into the UCI config files. On the other side, if it's an application which is not really developed by OpenWrt, could be something like Samba or Raccoon, anything which is not really developed by the OpenWrt community, then what we typically do right now is we write the init scripts for that, and the init scripts act more like an adapter or more like a translation layer between OpenWrt developed modules and the non-OpenWrt modules. And the init script has the ability to talk to the config file, which could be a samba.conf, or to the UCI file corresponding to the Samba. So that's the methodology which OpenWrt uses when it integrates a third-party application. This is what we see. So we try to imitate, because there is a huge advantage. In this model, there is no awareness of one on the other. So there is an adapter, which is the scripts in this context, and they can both work without major changes or major dependencies between the modules. So that's what we did as part of 7.x. It's very abstract, so please bear with me because it's a 20-minute talk. It's tough to give out all the details, but we exactly try to do the same. So we try to create a framework or an Intel framework where we solve the problems related to carrier readiness, TR69, multicast, DSL. These components don't exist in the OpenWrt world, and we want to really put them as a third-party application. So what you see here is we still register all the daemons with PROGD. We work with UCI. For parts where we are really using the services like network is really managed in the reference kit using netifd. So we still use the UCI. And for other parts which are more self-sufficient or self-contained, we fall back to the Intel framework or the UGW. So this whole package together is what we call as UGW today. So that's at a very high level, the design principles we have used in developing this software and trying to keep the dependencies clean. So moving on, this is how it looks if you get if you work with Intel and you try to get a documentation on what the software. So this is typically how the software architecture looks. What I gave before is a slightly different perspective on how do we work with OpenWrt, but if we want to look at the system completely, what you see is different daemons, management interfaces like Web TR69. There is a common adaptation layer, and there is a service daemon, which is managed by ProgD. Again, it's not independent of ProgD. Process daemon is still the owner of the whole system. And then you have services more in line with the TR181 or a TR98, depending on what we are trying to run. And for some of these parts, we use XML, and that's the master database. But there is also a provision to synchronize the XML database with the UCI database. This provision exists, and we use this on a need basis. So that's the high-level view, and what you can also see is a FAPI. That's the fundamental block we still use, and that's the block on which all our customers try to interface if they have their own, their own system software. With this, we also had the question. So that's a lot of stuff around carrier readiness and so on. But what if there is a customer who is really not interested in all this stuff? He's really just a wireless router. He's not interested in carriers. Could we still come back and put a vanilla OpenWrt? Is this still possible with this architecture? So luckily, because of all the design decisions we took carefully, so this is still possible. And what we have is a pure OpenWrt, or what I would like to call as a vanilla OpenWrt. There is no tampering here. There is no change to any of the processes. It's possible to now boot up a system completely, an Intel reference system with a vanilla OpenWrt framework, and that relies heavily on FAPI. So all the init scripts are modified to make sure that the FAPI is used, but the rest of the system from OpenWrt remains exactly the same. So there is no change. So that's the good part. So the architecture blends itself between a very carrier-focused distribution to a pure vanilla wireless LAN, wireless router kind of a distribution. So this is available now. You don't see a wireless LAN. That's still work in progress. It's coming. There's an internal plan. But that's the OpenWrt way of working. Yeah. So that kind of wraps up a high-level view or a bird's eye view of how do we use OpenWrt. So I would like to quickly say in a few minutes, where do we want to go further from here? So that's the same release calendar what I have shown in the beginning of the discussion. Now I just tried to plot what happened eventually after 3 years. Now where do we stand? That's a lot of activity on the right side. What you see is there is a lead formation, but lead is again coming back. We are all merging into OpenWrt. This is the wish from everyone. So good to see a lot of progress, but really good to see that there are a lot of releases. That's really motivating, and good to see there is even a 0.4 version out just a few days back. That was really fast turnaround from the community. So that's excellent. What we see on the purple is definitely the CIG formation has led to a lot of discussions. There are multiple companies also outsourcing the TR69 stack. We also have a SCAL, which is work done inside the CIG group, which also opens up the possibility to interface with the TR69 or a netconf YANG kind of a data models. So that, for us, that internally is very encouraging, and it opens up a lot of possibilities. That's how we see the last 1 year. And again, that's thanks to all the efforts from everyone. That's really good and encouraging for us. We would like to migrate to the latest OpenWrt. So as I said, we are based on Chaos Comma. It's not the latest. We know there are more versions out there. We would do that in the eventual, in the coming months. We would see a migration to the latest OpenWrt. We are also evaluating SCAL. Exactly like what other colleagues said, we had a lot of patches on the kernel. We would like to minimize the patches, try to align the content with the standard Linux configuration. And we would like to also make sure that the low-level APIs are more standard Linux-based, like CFG 802.11 is one proposal on the wireless LAN side. So that's wherever there is already a sysfs or a facility available in the Linux kernel. So that's what we would like to use. And finally, for a stack-independent API, we are looking at something like a FAPI. There was already a proposal made from Intel in the Purple committee. It may be FAPI, maybe something like FAPI, but we are very eager to close this topic because it's beneficial for all the players. So the same asks, what are the wish list? If we want to talk about the wish list, it would be good if we can get the community and the ecosystem to develop so that we say the OpenWrt becomes the base SDK. There could always be innovation coming on top. That's good. But there is also not a lot of advantage in keeping a lot of different distributions. So our interest is definitely in making sure that we go towards one common SDK, and if OpenWrt can help get there, that would be really great. The other topics, what we discussed, there are missing pieces. For some, it might be critical. For some, it may not be critical. I think that's fine. But if you can follow some of those topics, that would complete the distribution of OpenWrt, make it more compatible with all the other use cases as well, not just the wireless router. And FAPI, we just discussed it. So I can skip over this part. Yeah, that more or less gives me the final slide. So we would like to continuously support. We are really looking forward for a strong and bright future for OpenWrt. So thank you.
Thank you, Syam, and thank you, Intel. Again, it's great to see industry companies come together with community. And the next talk by Benjamin is going to give us some local flair. You can see that he probably didn't have to run his talk by the legal counsel or the marketing council. His talk is entitled F the Cloud. So let's see what Benjamin has to say.